Now see question number 4. Find the shortest distance between the lines x plus 1 by 7 equals to y plus 1 by minus 6 is equals to z plus 1 by 1 and x minus 3 by 1 equals to y minus 5 by minus 2 equals to z minus 7 by 1. So we have to find the shortest distance between these two lines. So we use the concept when equation of lines are x minus x1 upon L1 is equals to y minus y1 upon M1 is equals to z minus z1 upon L1 and x minus x2 upon L2 is equals to y minus y2 upon M2 is equals to z minus z2 upon N2. Then shortest distance between them is d equals to, in numerator we write here x2 minus x1, y2 minus y1, z2 minus z1 in first row, and in second and third row L1 M1 N1, L1 M1 N1, and in third row L2 M2 N2, and in denominator, in root we write. Now see how to write the denominator. When we consider this value x2 minus x1, so we skip first column, first row. So we calculate the determinant of M1, M2, N1, N2. So we write here M1 into N2, M1 into N2 minus M2 into N1, h square plus, then when we consider second element, so we skip second column first row, we calculate the determinant L1, N2 minus L2, N1, h square plus, then when we consider third column, we skip first row, third column, then we calculate determinant L1 M2. So we write here L1 M2 minus L2 M1 h square. So by using this formula we find the shortest distance between these two lines. For that we have to compare given equation and first find value of x1 y1 z1, x2 y2 z2, and then L1 M1 N1 and L2 M2 N2. So we calculate first numerator. For that we compare the given equation. So we write given equations as, so we write given equation for comparing with these two equations. So first equation we write as x minus minus 1, because minus minus get plus 1. Then this y plus 1 we write y minus minus 1, and this z plus 1 we write z minus minus 1. So when we compare this equation with this first equation, we get x1 as minus 1, y1 as minus 1, z1 as minus 1, and these are the values of L1, M1, N1. So we write L1 1, M1 minus 6, N1 1. Similarly, this equation we compare with this second equation. So from this second equation, after comparing, we get x2 as 3, y2 as 5, z2 as 7, and value of L2, M2, N2 are 1, here 7, then minus 2, then 1. So we have to calculate the value of this numerator first. So we write here x2 minus x1, y2 minus y1, z2 minus z1 in first row. So x2 minus x1, that is 3 minus 1, so minus minus get plus, so we write plus 4. Then we have to write y2 minus y1, y2 is 5, y1 is minus 1, so plus 5 minus minus plus 1, so we write here 6. Then z2 minus z1, z2 is 7 and z1 is minus 1, so minus minus get plus 1, so 7 plus 1 we write 8. In second row L1 M1 N1, which is 1 minus 6 1, so we write here L1 as 7 and here is 1, so we write L2 as 1. Now replace the value of L1 M1 N1. L1 is 7, M1 is minus 6, N1 is 1, then L2 is 1, M2 is minus 2, N2 is 1. Now we have to solve this determinant. So write here plus minus plus for first row. So 4 in bracket minus 6 into 1 is minus 6, minus minus plus 2 into 1 is 2, then minus 6 in bracket, 7 into 1 7, 7 minus 1 into 1 is 1, then plus 8 in bracket, 7 into minus 2 that is minus 14, minus minus plus 1 into 6 is plus 6. So we have to write this value. So we write this as minus 6 plus 4, which is minus 4. So 4 into minus 4 we write minus 16. Then 7 minus 1 is 6. Minus 6 into 6 we write minus 36. Then minus 14 plus 6 we get minus 8. So 8 into minus 8 we write minus 64. So after adding this we get minus 116. Now then next we have to find the square root of this. So if you observe these terms, m1 n2 minus m2 n1, that means we have to take 8 square. So we take directly value minus 4 8 square. So you can check yourself. This m1 n2 minus m2 n1 is nothing but this first value. Then this L1 L2 minus L2 L1 8 square. This is second value and third value is this. So directly we write here this first bracket as minus 4. So we write minus 4 8 square plus in bracket, then 6 square plus minus 8 square. So this we get minus 4 square is 16, 6 square is 36 and this 8 square is 64. So after adding this we get value 116. Now we have to find the shortest distance. So substitute these two values, value of this determinant and value of this square root. So we write here therefore d is equal to, we get the value minus 116 upon square root of 116. So we get value here minus square root of 116, because numerator we write root 116 into 116. So one root get cancelled. So this is the distance. So distance is always positive. So d is equal to mod of under root 116, which is equal to under root 116. So in this way we find shortest distance. This problem is not difficult, but it is lengthy. So solve carefully or write the values of this L1, M1, N1. Now see question number 6. Question number 5 is similar as question number 2nd, so you can solve yourself. Now see question number 6. If A of 104, B of 0 minus 11 13, C of 2 minus 3 1 are 3 points, and D is the foot of perpendicular from A on BC, find the coordinate of D. So first we see here what we have to do diagrammatically. So we have to find equation of BC first, because here given D is the foot of perpendicular from A on BC. So when we draw perpendicular from this point A on this line BC, so this perpendicular is at point D. So D is foot of perpendicular. We have to find the coordinate of that foot of perpendicular. So first we find the equation of line BC. Then from that we know that when a point lie on a line, then that point satisfy the equation of that line. So we use here concept, if line equation of line is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So this is a 2-point form. So from this 2-point form we find the equation of BC. So when we compare the coordinate of B with x1, y1, z1, so we get here x1 as 0, y1 as -1, z1 as 13, and here x2 as 2, y2 as -3, and z2 as 1. So we can find the equation of BC. Therefore, equation of BC is x minus x1, x1 is 0, so x minus 0 upon x2, x2 is 2, so 2 minus 0 is equals to y minus y1, y1 is minus 11, so minus minus get plus 11 upon here y2 is minus 3, so minus 3 plus 11 is equals to z minus z1, z1 is 13, so z minus 13 upon z2 minus z1, z2 is 1, so 1 minus 13. So we can write this as x by 2 is equals to y plus 11 upon 8 plus 8 is equals to z minus 13 upon minus 12. So we consider this as lambda. So from this we can find any point on this line, and that any point we consider as a D. So we write here, therefore any point on line BC, BD. So we write the coordinate of D as D equals to, when we write x value of x, so we write x is equals to 2 lambda, so first coordinate is 2 lambda, then y plus 11 upon 8 equals to 8, so we write here 11 minus 8 lambda, and third z equals to minus 13, so we write plus 13 minus 12 lambda. So, or you can add one more step for your convenience. So we write here x by 2 equals to lambda, y plus 11 upon 8 equals to lambda, z minus 13 upon minus 12 is equal to lambda. So from this you can easily calculate x is equal to 2 lambda, y plus 11 equals to 8 lambda, z minus 13 equals to minus 12 lambda. So value of x is equal to 2 lambda, y is equal to minus 11 plus 8 lambda, and here z is equal to plus 13 minus 12 lambda. So the coordinate of point D are 2 lambda, minus 11 plus 8 lambda, and 13 minus 12 lambda. Now, therefore, the direction ratio of AD are, so from this coordinate of point D and coordinate of point A, we can find the direction ratio by using the formula x2 minus x1, y2 minus y1, z2 minus z1. Therefore, the direction ratio of AD are 2 lambda minus 1, comma, minus 11 plus 8 lambda minus 0, then 13 minus 12 lambda minus 4. So you can write this as 2 lambda minus 1 minus 11 plus 8 lambda, 13 minus 4, which is 9. So we write 9 minus 12 lambda. These are the direction ratio of AD. Now we find direction ratio of BC. Therefore, the direction ratio of BC are, so from this BC, so we write here 2 minus 0, 2 minus 0, then minus 3 minus 11, minus 3 minus 11, so minus minus plus 11, 13 minus 1, 13 minus 1, so we write here 2 minus 0 as 2 minus 3 plus 11 as 8, then minus 13 minus 1, we write 12. So the direction ratio of AD are known, direction ratios of BC are known. we here from diagram AD perpendicular to BC, so we use when two vectors are perpendicular, then their dot product is 0. So from using that, we find the value of lambda first. Here we write 13 minus 1, that is 1 minus 13. So we get here minus 12. So we use dot product since AD and BC are perpendicular. Therefore, we take their product equals to 0. So we write here 2 lambda minus 1 into 2. 2 lambda minus 1 into 2 plus minus 11 plus 8 lambda minus 11 plus 8 lambda into 8 plus 9 minus 12 lambda 9 minus 12 lambda into minus 12 is equal to 0. So we have to multiply these two brackets. So 2 into 2 4 lambda minus 2 plus minus 8 into minus 11 into 8, which is minus 88 plus 64 lambda plus minus 108 minus plus 144 lambda is equal to 0. So from this, first we find the value of lambda. So this, when we add value of lambda, so first we collect the values of lambda. 64 plus 4 plus 144 into lambda. Then this minus 2 minus 88 minus 108 is equal to 0. So from this we get value of lambda. So we add these 3. So we get here 212, that is 212 lambda minus 198 is equal to 0. Therefore 212 is equal to plus 198. So lambda is equal to 198 upon 212. So we can divide this by 2. So we get 99 upon 106. Now this is value of lambda. When we substitute this value of lambda, so we denote coordinate of B as equation number 1. So while substituting the value of lambda, we get the coordinate of point D. So from equation 1, we get coordinate of D as 2 into lambda. Lambda is 99 upon 106 minus 11 plus 8 into 99 upon 106, 13 minus 12 into 99 upon 106. So after substituting the value of lambda, we get value like this. Therefore now you can divide each term by 2. So you can simplify further. So you can write up to this is sufficient.